Hello everyone, my name is Gabriel Hernandez and I am a student at the University of Florida, pursuing a bachelor's in electrical engineering and economics. I am currently doing research on the supervision of Dr. Dominic Forte in hardware security and more specifically in AMS primitives. Counterfeit electronics impact the global economy and pose a critical cybersecurity threat to vital systems and infrastructures in our society today. Recycled counterfeits are chips that have been extracted from printed circuit boards and have been placed back into the market to be falsely sold as new components. There are many different countermeasures for avoiding the use of counterfeit digital chips that have proven to be effective, such as the use of physically unclonable functions and silicon odometers to detect any changes to the chip's parameters before they are reintroduced to a new system. However, analog mixed signal chips or AMS chips are the most widely reported counterfeit chip type, and current countermeasures have proven to be flawed and impractical. My area of research focuses on finding the best alternative to detecting AMS counterfeits that exist in the market today. One of the methods to determine whether an AMS primitive is counterfeit or recycled is by understanding and analyzing LDO circuits. Given that these circuits are an essential component in most power supplies of analog mixed signals chips nowadays. In simple words, an LDO is a linear voltage regulator that has the ability to have a very low voltage drop across it. The two main functions of an LDO is to regulate the input supply voltage to the voltage required by the load and to supply a very low noise output voltage. Some important components to keep in mind in the basic architecture of an LDO are an error amplifier with a high open loop, a constant DC reference voltage, the output voltage, which is determined by the values of this reference voltage and by the R1 and R2 resistors that can be seen in this image. A MOSFET acting as a pass transistor to achieve regulation by controlling negative feedback. And finally, the capacitor at the output, which value will be determined based on the load current. These are some of the most important LDO parameters that can be used to compare agent effects between a new AMS chip versus a counterfeit or aged AMS chip. In previous works, the power supply rejection ratio proved to be effective to detect counterfeit chips, but it also proved to be impractical as it required extensive data measurement over different frequency ranges using very ineffective external measurement mechanisms. For this reason, we determined that standby current could potentially be the best parameter to use for further development of an AMS design that will effectively provide accurate data. The good thing about standby current is that it can be easily measured on chip, meaning that there's no need for external measurement methods, and it is not depending on frequency. This new way to identify recycled chips does require a new LDO design that integrate a current sensing circuit for an on-chip standby current calculations. However, this will lead to faster ways to determine whether the chip, an AMS chip is recycled or counterfeit, and it will hopefully also provide very accurate data and using learning algorithms, we might be able to also determine the amount of time that is been the circuit or the primitive has been aged for. Thank you very much for tuning in, and if you have any further questions, don't hesitate to contact me.